Acids are a type of compound that are really in between molecular compounds that are covalently bonded and ionic compounds that are made of ions. So the definition that we're going to use for an acid is that an acid forms the H plus ion when it dissolves in water. And the acidic hydrogen, is covalently bonded to the acid molecule when it's in its liquid, gas, or solid state. And then when the acid dissolves in water, the acidic hydrogen breaks apart from the molecule and forms the H plus ion. Now, just because a molecule has a hydrogen atom doesn't mean that that hydrogen is acidic. But for our purposes, an acid must have a hydrogen in it. And when we write the formulas of acids, our hydrogen is always going to be at the beginning of the formula. And we're going to look at two different types of acids. The first type we're going to refer to as binary acids because there are two elements in them. And we are only going to focus on the binary halogen acids. So the name of these all have the prefix hydro. They have the root of the element, and then they end in ic, and the word acid is included. So if we look at the slide here, HBr, hydrobromic acid. HI, hydroiodic acid. If we look at the other halogens, HF would be hydrofluoric acid, and HCl would be hydrochloric acid. So we'll only be looking at 4 binary acids, and you should know their formulas and their names. Now the next type of acid your text refers to as oxoacids, and this is because they are based on polyatomic ions that have oxygen in them. Now there are 2 items that I want to address. One, the name of the acid depends on the polyatomic ion, and the formula of the acid depends on the polyatomic ion. So whatever the charge of the polyatomic ion is, -1, -2, or -3, that determines how many hydrogens are in the acid. So if the charge is -1, there's 1 proton or 1 hydrogen. If the charge of the oxoanion is -2, then there are 2 hydrogens. -3, 3 hydrogens. Now let's look in detail at how the name of the acid depends on the polyatomic ion. Oxoanions are either going to end in ate or in ite. And if the polyatomic ion ends in ate, then the corresponding acid is going to end in ic. So I remember this by I ate something icky. And then if the polyatomic ion ends in ite, then the corresponding acid is going to end in us. And I remember this by I and us. So if we look at this table on this slide, we see the 4 chlorooxygen anions, hypochlorite, ClO-, chlorite, ClO2-, chlorate, ClO3-, and perchlorate, ClO4-. Each one of these ions has a -1 charge, so the formula of the corresponding acid will have 1 hydrogen. 2 of these polyatomic ions end in ite, and 2 of them end in ate. So there will be 2 acids that end in ic and 2 that end in us. So let's look at hypochlorite, ClO-. The corresponding acid will be HClO, and its name will be hypochlorous acid. We must include the word acid, and we see that the suffix has changed from ite to us. The next ion, chlorite, corresponds to chlorous acid, HClO2. And ClO3-, chlorate, its corresponding acid is HClO3, chloric acid. Since the suffix was ate, the suffix of the acid is ic. And perchlorate, the anion perchlorate, the corresponding acid will be HClO4, and in the formula, and the name will be perchloric acid. All right, so it's really important that you know your polyatomic ions, and if you don't, please refer to page 141 of the text, which has their names as well as their charges. So go ahead and pause the slide and see if you can name these acids. So if you got hydrochloric acid for the first one, excellent. It's a binary It's a binary acid. The second acid, H2CO3, is an oxoanion acid, and the anion, carbonate, CO3 2-, has a charge of -2, so we see there are 2 hydrogens here at the beginning. The polyatomic ion carbon 8 ends in 8, so the corresponding acid will end in -ic. So this is carbonic acid. Now the next one, H2SO4, is based on the oxoanion sulfate. So we would think that this should be called sulfic acid. It's actually called sulfuric acid. We have an extra syllable in there. And also notice that the -2 charge of sulfate means that the acid has 2 hydrogens. Now I wanted to point out another exception. Here is H3PO4. This acid is based on the polyatomic ion phosphate. Phosphate has a charge of -3, so the corresponding acid has 3 hydrogens. Now, based on a rule that 8 goes to -ic, this acid should be called phosphic acid. However, like sulfuric acid, we add an extra syllable in there. So this is actually phosphoric acid. So I just wanted you to be aware of those anomalies in naming. The suffix is still the same, but we just add an extra syllable.